شكرا لحضوركم هيدي الجلسة. Sorry, I lost. يلي بالإضافة إلى زوم ستبث على فيسبوك المجلس والتي ستعقد بالإنجليزية. I am Nada Shaya, the program lead of the Arab Social Science Monitor at the Arab Council for the Social Sciences. Thank you for attending this session about optical character recognition of Arabic text, OCR, and we look forward to the demonstration of Dr. Hegghammer. The webinar will present the methods used in an ongoing project at the University of Oxford and the University of Wisconsin-Madison to extract plain text from historical and new issues of al-Ahram newspaper. Before I give the floor to Dr. Hegghammer, I want to take a little bit of your time and talk about the Arab Public Data Initiative under which we are having this demonstration. The three partners in this initiative are the ACSS, the Odum Institute for Research in Social Sciences at the University of North Carolina in Chapel Hill, and as of 2023, the University of Oxford, and it's the University of Oxford who suggested having this demonstration. The Arab Public Data Initiative has two main objectives. The first one is the provision of data sharing infrastructure for the long-term preservation of social science research data on and in the produced on and in the Arab region, and to facilitate access to this data. To this end, we established an open access multidisciplinary data repository. It's called the ACSS Dataverse, and my colleague Rami is going to put in the chat box the link to this repository. This archive is available to both individuals and research institutions to deposit their data sets, and of course, it's free of charge. The second aim of the initiative is building capacity in managing research data. We hold training workshops across the Arab region that introduce the principles and best practices and tools of research data management. During these workshops, we introduce the FAIR principles, research data management plans, open science, etc. And the training material are available in both Arabic and English. I will stop here talking about the initiative. If you have any questions, please feel free to reach out to us. The email will be put in the chat box, and also if you're interested in depositing data sets in our repository. Without further ado, I will introduce Dr. Hegghammer. Dr. Thomas Hegghammer is Senior Research Fellow in Politics at All Souls College at the University of Oxford University. He is a political scientist and historian who specializes in the study of militant Islamic groups. His most recent books include The Caravan, and the second one is Fight, Flight, Mimic. He also has an interest in computational methods for scientific and historical research, and has written several R packages, including DAR, which provides an R interface for optical character recognition with Google Document AI. Welcome, Thomas, off to you.
Thank you very much. I'm delighted to be here, and thank everyone who's taken time off following the dramatic events in the region to do a bit of nerding here with me on optical character recognition. I want to start with thanking ACSS and you, Nada, for hosting this, and I also want to thank a few people who helped set this up, including Sausan Najjar, Neil Ketchley, and Charlie Kurzman. As the slides suggest, I hope you can all see the slides. I'm going to talk about text extraction from historical documents in Arabic. This is something that has interested me for a while because I come from the humanities in a way. I've done sort of qualitative research most of my career, and in my study of sort of the history of militant Islamist groups, I collected a lot of primary sources, and as my collection grew, I started getting, problems handling all this data and finding things in them. I couldn't, and I realized that a lot of the documents were not searchable. So I sort of, for the past sort of 5 years, I've been on a quest to solve this problem, and I'm going to share some of my sort of insights with you today. Of course, another key motivation here, and the reason I couldn't solve my problem when I started, is that optical character recognition in Arabic is quite a different ballgame from optical character recognition in English. I'll come back to this later. So optical character, so there's a strong kind of bias in the research and the technological development in this area, a bias in favor of Latin script in general and of English in particular. And anything that is not Latin script based, like Arabic, suffers, and there just aren't as many good tools as there are for English. So we historians and others who work on Arabic language materials are kind of left to our own devices, trying to find solutions. So I just want to start with a kind of describing the basic problem, and I'm sure you have all encountered this. So here you see two documents. The one on the left is a PDF printout of a Wikipedia article. So it's a and those types of documents that are born digitally, they're born on a computer, they're generated on a computer. The text in PDFs is usually searchable and copy pastable. So you can mark things and you can paste it into other documents without any problem, and you can search Control F, etc. No problem. But then I'm sure you've come across PDFs or other documents where you can't do that. For example, if you scan a document or scan an old article in a scanner, you get it onto your computer, you try to mark the text with the intention of copying and pasting it, and you can't. The computer won't let you. And that is because what you're really looking at is an image. So a PDF can sometimes have the text hard-coded in it, in which case you can copy, paste, or search. And in other cases, the PDF is actually an image, and the text is not embedded in the document itself. And then, and when that is the case, you don't have access to the text itself. So I'm including just as a sort of an example document, a document that is definitely not born digital, because it was printed as early as 1764 in the monastery of Shuwair in Lebanon. It's a work of Christian theology. But it's just for illustration here, and it's but the if we're talking about kind of historical documents, the vast majority of documents will be of this kind. They will be sort of not born digitally. It's really only documents that were generated on a computer sort of post 2000 that have the text hard coded in it. So everything else, the centuries of printed or materials before that is generally not accessible to search or copy paste or other text analysis methods. So maybe some of you have tried ways around this. You may have seen that the Adobe Acrobat, the most widespread PDF reader, has an OCR functionality, which works reasonably well for English and European languages, but it doesn't have an option for Arabic, at least the version that I have had access to. Now there are you will, and then next on your quest to sort of decipher your PDF, you will probably have gone online. You will have Googled OCR Arabic PDF, something like that, and you will have come across a bunch of different online services that purport to, or that promise to OCR your document. And you will have discovered that there too, Arabic is often not included as an option. So Adobe has an online service called Adobe Acrobat Online, which doesn't have Arabic. There's another widely used one called onlineocr.net, doesn't have Arabic. So no luck there. Now, there are some online services that do have Arabic. One is called Convertio.io. There are a few others as well. And you can upload your PDF, press the magic button, and you'll get a text file back. However, the quality of the text recognition is usually not very good. So here's the output that we get from our 1764 page. Is basically gibberish. It's not usable at all. Now, part of the reason for this is that optical character recognition is a difficult computational procedure that is sensitive to many things. There are many different things that can throw it off and make it read things wrong, it's so the thing that these OCR engines like the least is visual noise. So whenever you have shading or speckles or some unclarities or I don't know, sort of signs of folded paper, or if the scan is a little bit off, all these things can throw the OCR engine off and give you a poorer result. And we're going to see several of the examples of that a bit later on. The point is that there isn't sort of a quick fix in these online OCR tools. Now, there are other sort of more specialized PDF programs that have OCR. Like, so there's something called Abby Fine Reader, which is sort of an alternative to Adobe Acrobat. And Abby has Arabic OCR as an option. But here too, the results are not great. It's somewhat better than what we get from the online free services, but it's still not great. I mean, if you were to use this, you would have to do a lot of post-processing as a kind of manual correcting of the output. And it's worth noting that Abby Fine Reader is only available for Windows, and it costs money. And personally, I wouldn't pay for this if OCR was what I was after. There is, however, one sort of manual solution that works quite well, and that is Google Docs. You can open a PDF in Google Docs, and it will transform it into a text document and OCR it in the process. And the output here is really quite good for a free product like this. You will see here that it only makes 2 small mistakes. Otherwise, the transcription is correct. The reason why Google Docs does so well is because it uses Google's proprietary OCR engine, which is what we'll be relying on later on in this presentation. So Google has developed the most powerful optical character recognition engine for Arabic and for non-Western languages. So, and that's what is being leveraged here under the hood. I should say that when we come back to the Google model later on, it's a slightly different version of it, one that is even more powerful. But if you have one or a handful of documents that you just want to get OCR'd, then Google Docs is a pretty neat solution. But that's only if you have a small number, because you have to open the PDF manually in Google Docs. What if you have thousands or tens of thousands of documents? Well, then Google Docs isn't really an option anymore. That's when we need programmatic solutions, meaning solutions involving computer code, like R or Python. Now, broadly speaking, here there are two types of options available. Either a kind of is to either do the OCR with a local model, like a model that lives on your computer, and that it's open source, meaning free and available to all, or to use a server-based model from one of the big companies like Google or Abbey or Amazon. The local open source approach via models like Tesseract, Kraken, or others they have the benefit of being free, being privacy friendly because no data leaves your computer, and of being trainable. You can, if you know how, you can fine tune either of those models and tweak it if you have a corpus of documents with particular features that can be addressed through tweaking. The downside is that these models are a little bit more kind of fidgety than the server-based ones, and it takes quite a bit of extra kind of programming to get good results. It requires more labor essentially to get very good results, especially on sort of historical scans, for example, which typically have noise in them, visual noise. I'll come back to what that sort of tweaking consists of. With regard to the server-based models, they have the advantage of delivering very good results out of the box with no need for pre-processing or tweaking. But on the downside, they are not good if you have very sensitive documents with sort of personal data or anything like that, because it does go into the cloud, onto Google's or Amazon's servers. They say they don't store it and that they don't use it for training, but still, I mean, if you have very sensitive information on your documents, you probably won't be comfortable with this solution. Another downside is that it does cost money, although not as much as one would think. For example, Google Document AI lets you OCR around 1,000 pages for $1. So depending on the size of your corpus, that can be manageable. It's also possible, by the way, to get. I should mention that especially some of these services often have like a free starter token. So with Google, for example, you get $300 worth of credits when you start using the service, and that gets you quite far. It's essentially 300,000 pages that you can use for free, OCR for free. You can also sometimes get grants from Google Education and so on for academic projects. So I'll just show you briefly how one would do this with Tesseract, probably the most famous open source model. I'm using R here mostly, the programming language R, and to OCR a page with Tesseract in R is few lines of code, really, and this is what it gives you out of the box. So I would characterize our sample document, this 1764 document, as a kind of medium level of a document with medium level noise, and for that, the Tesseract does not give us a very good result out of the box. It's on I would say kind of on a par with some of these online services, which is, by the way, I suspect that several of these online services, they are actually using Tesseract under the hood to OCR documents. But you can tweak the pipeline by, for example, by pre-processing. So there are things you can do with code to kind of clean up the document. So here in the middle, you'll see a sort of the cleaned up version that you can get. So I've taken away all the sort of the frame around it. I've made it black and white. I've removed some of the speckles, etc., so that it's clearer and easier for the OCR engine to read. And we get much better results, as you can see on the right-hand side. However, as you can see on the left-hand side, you need to write all this code that's tailored to that particular page in order to get that result. Now, sometimes if you have a larger corpus, that can be manageable. If you have a large corpus where most of the documents are very similar, then it might be worth it, because then it's you use the same pre-processing script for all of the documents. But if you have a heterogeneous corpus with different levels or types of noise, then the Tesseract is going to be labor intensive for you. This is where these server-based models come in. And there's really, I mean, as far as Arabic is concerned, there's really only one game in town, and that's Google Document AI. Abi Fine Reader API also has Arabic, but it's considerably more expensive and not quite as good. We can use Google Document AI from a variety of different programming languages. It doesn't really matter. I tend to use R just because I do everything else in R and kind of fits well with the rest of the workflow. And here too, it's quite simple. It's a few lines of code again, using the DARE R package. This code basically takes your file and it sends it to the Google processor and returns text. And as you can see here, it's impeccable. It's essentially, there are essentially no mistakes in this particular job. Now, Google Document AI is not perfect. Depending again on the level of noise and so on, there will be occasional errors, but this is as you can see, a very good transcription, and it's it required no pre-processing, and by the way, you get this back in a matter of 2 seconds. So it scales well. You can process thousands of documents in hours. What's interesting is that the Document AI processor is getting even better and better on handwriting as well. So here's an example from a handwritten page that my collaborator Neil Ketchley was interested in transcribing for his project on the 1919 revolution in Egypt. And Google Document AI does a pretty good job of transcribing it. It has more errors than the printed page, but still, I think this is quite promising. But because we have to bear in mind that these are technologies that are constantly evolving, and really, with everything linked to artificial intelligence, and we now have these incredibly powerful proofs of concepts that, for all their current flaws and limitations, it's really only a question of time. Give it enough time, these technologies are going to just get better and better and better. And so presumably handwriting OCR will continue to improve to the presumable delight of historians. Oh, I should mention, by the way, that the Google Document AI engine has a kind of a demo where you can upload individual documents. It will give you sort of an idea of what it can do with your document. The link is in the link at the bottom of the slide. I'll be happy, by the way, to share these slides if there is interest and a way to do that. So far we've looked at pages that are quite simple, but often when we're dealing with magazines or newspapers or posters and whatnot, the layout can be more complex than that. And I want to, just to illustrate, I want to start with a slightly more complex layout, because it's an introduction to the biggest sort of unsolved problem in OCR, which is the layout parsing problem. So if you take a document like this, so this is an excerpt from the Moroccan Constitution, the project that I'm peripherally involved with, together with Selson Najjar. So here you have essentially a two-column text that it takes a human a few seconds to kind of orient him or herself here to see that it's from one and the same page, given the header, but we see that there are two separate columns, and we know that it should be read. You read from the top right to the middle and then continue downwards. And then when you're at the bottom of the first column, you continue at the top of the second column and continue down. However, this is not obvious to an OCR engine at all. Because you have to remember that fundamentally what these engines do, they take the image like any other image, and they see just lots and lots of pixels, and they don't have a sort of sort of built-in idea of kind of columns and paragraphs and kind of sort of these sort of intuitive layout parsing intuitions that we humans have. So if you try and OCR something like this, you're very likely going to get garbled text. So I don't know if this slide is not a very good slide, is it, for video link presentations? But essentially, on the left hand you have the original, on the right hand side you have the transcript that we get from Google Document AI, essentially the best Arabic OCR engine out there, and it's the individual letters and words are correctly rendered, but they're in the wrong order. We see it goes from part 3 and 4 to 14 and 15 to 5 and 6 again. I mean, it's just word salad or sentence salad, at least at this point. And you can't. This is you can't really use this for anything other than sort of bag of word analysis. So what is going on here? Well, it's that Document AI doesn't understand where one column ends and another begins. So here are the this is how Google Document AI reads the document, and we know this because when you send something to the OCR processor, they give you back not only the text but a lot of other metadata, including coordinates on the page where it found the different words and letters and so on, and you can use it to visualize the reading made by the processor. And here we see that it's taken it's basically continued along horizontally along the line onto the second column, where in fact it should have continued downwards. And so this is why they get mixed up. And this and this is something you find in practically, I mean, you find it in all OCR engines to a greater or lesser degree. It varies. I mean, some engines are better than others. Google Document AI is pretty good at layout parsing, better than some others. But it also varies by document. So depending on how clearly the columns are situated from one another, the layout parsing of the engine might be better or worse. If you take a look at, for example, Tesseract, this is Tesseract's reading of the same text. Now, Tesseract, we can't get sort of block level visualizations of Tesseract readings, but we can get it at the word level, and we can look at the numbering, and we can see that Tesseract also continues along horizontally and reads it as if it was a single column text. So, single column text, and so here too we get word salad. Now we can imagine if having even more complex cases. So the 2 columns example is the simplest possible variant of the layout parsing challenge. There are lots and lots of cases out there with very complex layouts. For example, the one on the left, we had kind of a diagonal, or sort of you had triangles of text. Or the one on the right, the first issue of Arab News, where we have really quite a complex layout, which humans can understand. Humans know where one small article ends and another begins, and so on, but a computer does not. And so I haven't actually tried these tried OCRing these with either Tesseract or Google Document AI, but I'm almost certain that they would not read these correctly. So this was the problem that we face essentially in our project on the al-Ahram newspaper. But let me first just say a few words about that project. So we essentially, so this is essentially an ongoing project that I'm involved with, together with Stephen Brook at University of Wisconsin-Madison, Neil Ketchley here in Oxford, and Chris Barry at NYU. And we have been lucky to get our hands on all issues of al-Ahram newspaper from 1876 to 2020, which is, and I don't need to tell you how central al-Ahram newspaper is to the history of Egypt and of the region, but it's worth pointing out that this is, as far as we know, the longest running print series in the Arabic language. So it's really a treasure trove for, at least for kind of longitudinal studies of political, social, cultural change. The background here is that the University of Wisconsin-Madison Library purchased a digital copy of the collection from Eastview, a publishing company, and that we have been given access to the collection, and the collection is enormous. We have before us 650,000 pages, spanning these 145 years. But the problem with it, it's that the layout on the pages is very complex, as you can see here. Multiple columns, headlines spanning several columns, but not always the same number of columns. So one headline on the right there spans 2 columns, and the other headline on the left spans 4 columns. And the layout is not the same from one issue to another, let alone from one year to another. So while it's kind of broadly the same in sort of long columns and black and white text, etc., they vary enough for it to make it impossible to use any kind of mathematical approach. For example, if it was different, if it was exactly the same number of columns of exactly the same width across the 145 years, it would be an easy task, because you could just slice the images mathematically according to the coordinates, and process each slice separately. But because it varies, that approach doesn't work. And we can see what Document AI makes of this. So this is the parsing of this page by Google Document AI, and it's all over the place, with some blocks effectively covering part of a column, but many other blocks spanning columns, and there's also overlap and kind of mysterious blocks in the middle of the text, etc., etc. So this is essentially not usable. So here again, we would get accurate character recognition, in the sense that the words and letters would be transcribed accurately by Document AI, but they would be in the completely wrong order. So we had to find another solution, and our strategy was to separate the layout parsing process and the optical character recognition process, and to use essentially a computer vision model to identify blocks of text, and then use the predictions of that computer vision model to cut out the identified blocks and OCR them individually. So I'm going to just quickly talk you through what that means in practice. Here's sort of a diagram showing the basic procedure. So we have we start with an original on the left, that we pass through a computer vision model. We're using a model that's based off of Facebook's Detectron-2 model, which can be used for almost all kinds of lots of different things in computer vision, but it's been trained by a team at Harvard that's developed a tool called Layout Parser. It's been trained to specially recognize kind of elements on a page, text blocks or illustrations and so on. And then we have fine-tuned that model using annotations on our documents. And that fine-tuned model then produces what we call block predictions. So basically, the coordinates of the pieces of the page that should be read individually, and then we use those coordinates to programmatically cut out those bits, and we treat those cutouts as individual documents, and we pass them to Document AI for optical character recognition, and we get plain text at the end of it. So the sort of the laborious part of this procedure is the fine-tuning part, because you need annotations that are tailored to your corpus. So we were lucky to get to enlist the help of Atif Ahmed in Cairo, who annotated 300 pages of our collection for us in on a platform called Label Studio, and then we use those annotations to fine-tune a layout parser model. So notice how 300 pages was enough. We'll see that it was enough. 300 pages is I think it was, it was a lot of work for Atif. He worked for at least a month on this, but it's still a tiny slice of the 650,000 pages in the collection. So with annotation, just a few hundred pages, you can fine tune a model to good effect. And so this is what we get. So this, what you see on the right here, is the same page that. So let's rewind briefly to Google Document AI's initial layout parsing, all over the place, and this is the layout parsing by our fine-tuned model. You see that it finds all of the right column bits and all of the elements that should be read independently. And it's not just true of this one page. It's true of most pages in the collection. So here are two other random pages. You see how it works. Now you see that the accuracy of the layout parsing is pretty good, although not perfect. It misses out bits and pieces here and there. But it's mostly okay. So, but the main limitation of this approach is that we don't get it in the correct reading order. So the numbers tell us in which order the layout parser model has identified the blocks, but the numbers are not in the reading order. Now, this is an unsolved problem as of today, and it's a limitation of our project as it stands. But we have kind of hopes that this is a solvable problem. For example, with a large language model in the future. I'm personally quite confident that we'll find AI solutions to this type of problem. But it's worth also bearing in mind that for a lot of natural language processing techniques, not having it in exactly the right order is not such a big problem. There's still lots of useful things we can do and get meaningful results from with blocks like this. And then once we had a model that we knew worked, sort of a layout parsing model that we knew worked, we then we deployed it onto our massive corpus. And this was a huge job, and which is still ongoing, actually. As I mentioned, 650,000 PDFs. And because, let's rewind a bit again, you see on these images that the model identifies lots and lots of blocks in one page. So for each page, you can have tens of blocks, and each of them are sent individually to Document AI. So we will have made around 30 million processing requests to Document AI, and to make this last less than a remaining lifetime, we ran multiple scripts in parallel. And it still will have taken us around 6 months to do. And it will have cost us around $25,000 in total. But we've been lucky to get funding from Google Education. The bulk of the funding comes from University of Wisconsin-Madison, and then some from NYU and All Souls College. And the picture below there shows the machines that we did it on. We had to do it on bare metal rather than on a server due to a technical issue with the VPN access to the source repository of these of the original PDFs. So what do we get out of all this? Well, we get the plain text, as well as the kind of the location on the page of of each bit. So this is just a tiny little piece of the data frame that we have. So as I said, we'll have around 30 million blocks. So each row here is a block. So we'll have, so it's basically a spreadsheet. Think of it as a spreadsheet with 30 million rows, and one of the columns in that spreadsheet will have the plain text of the block in question, and it all adds up to around 3 billion words. I say around because we still haven't finished the processing. We're in the we've made it up to around 2010, from 1876 to 2010. So we're still not quite there yet, but we're aiming at around 3 billion. So I'm just briefly at the end. So I'm not going to. So because this is ongoing work, the processing itself is ongoing. We haven't been able to carry out any sophisticated analysis on this yet, but it's clear to us that it opens up for a very wide range of inquiries. For example, we'll be able to do search and semantic search across these 145 years. We'll be able to do frequency analysis or topic models to, for example, to trace the evolution of the prominence of particular themes or ideas, such as nationalism or something else. Or we can be able to use sentiment analysis to understand how different political events or actors have been perceived by those who write in al-Ahram over the years. With the vector embeddings, we should be able to capture changes in the connotation of concepts or names or other things. And with with large language models, there's lots more one can do. For example, you use it to code data sets, event data sets, or biographical data sets on leaders or something like that. I mean, this is just the tip of the iceberg, really, of what's possible. It's a tiny sort of teaser. I just want to show you one graph here produced by Chris Barry, one of my collaborator. It shows you the sort of the engram, or so the evolution in the sort of proportion, in the occurrence of the word ihtijaj, protest, over the years. We see that it kind of there are very few occurrences of it prior to 1909, and then it increases, and you see a big spike in the years following 1919. I mentioned this because in Neil Ketchley's work on the 1919 revolution, this is one of important his important findings from his other analysis, that protest is relatively new, and the 1919 revolution really kicks off sort of a multi-year spate of it, and we can see this in the language data of the Ahram collection. And one can imagine all kinds of inquiries of this kind on this corpus. There are probably more research projects to do on this corpus than our team can do in the remaining careers. So this is a major breakthrough, I would say, and an important resource. I just want to mention briefly also the byproduct of this procedure has been that we have also been able to extract the images, because the same computer vision models that identifies blocks of text identifies images, photographs or caricatures or other kind of graphics. So we have extracted all the images in all of al-Ahram from 1876 to 2020, over 2 million in total, which is exciting because with the rapid improvements in AI, there's more and more things we can do with images. Nowadays we can even do semantic search in images, which again opens up for a lot of interesting inquiries. But that's not. I won't go deeper into that because that wasn't the topic of the talk. The key point here is that it's now possible to extract text from Arabic historical documents with greater ease than before. The character recognition problem is largely solved. The main remaining problem is the layout parsing. The things are happening there, and I wouldn't be surprised if Google Document AI's processor becomes better at layout parsing out of the box, and that we won't have to use this middle step of a fine-tuned CV model in 5 or 10 years' time. So it basically means that centuries of printed text are about to become searchable and analyzable. Having said this, I still think that sort of one-click solutions are a while away, like a solution whereby you just kind of drag and drop a folder of 10,000 documents and the program will fix it for you. I think there's still needs to we will continue to have to do some kind of tweaking and programming in order to process things at scale for this type of purposes. But for those of you who are not familiar with the sort of the programming behind OCR processing, I will hopefully give a workshop for ASSS next year, where we can kind of go into detail about how to build scripts to OCR documents. So that was my talk, and I very much look forward to your questions. Thank you.
Thank you so much, Thomas, for a great presentation. And yes, we are planning to have an ASSS workshop led by Dr. Hegghammer on OCR for Arabic text. So we will advertise for it in due time. We have a few questions with the remaining time. We may go a little bit over time. The first one is, here it is. The results of Google Document AI are really impressive, but am I allowed to publish the documents, including the results? For example, the Arab 1724 from Gotha, copyright expired. Am I allowed to use the data for text finding? This is one question.
So as far as I'm aware, the use of Google Document AI doesn't come with copyright restrictions. So the copyright status, as far as I understand it, it's determined by the source of the status of the original image that you pass to Google Document AI. I have to say I'm not a specialist on copyright matters, which is becoming more and more complicated in my experience. But especially for research purposes, I don't think there are any constraints. I think that there may be other issues if you're doing it commercially. If you're using Google Document AI in an application for a company, in order to make money, then there may be special arrangements or agreements you have to get into with Google. But for academic research, as far as I understand, the OCR processing itself doesn't come with copyright restrictions.
Thank you. We had a couple of questions about your work on al-Ahram. I mean, it says, the al-Ahram corpus, will it be accessible, the work you're doing?
So this is something that we are trying to find out. The problem is that these documents are the source documents are owned by a commercial company, Eastview, and these documents are actually they are available in another form on Eastview's platforms, where you can browse the al-Ahram issues and kind of see the PDF, see the various pages. And they have done a rudimentary OCR already, which means you can search in it. And if the OCR has done the word that you are after, right, it will take you to that page. So Eastview has naturally imposed certain restrictions on kind of the dissemination of this material. So I think it's unlikely that we'll be able to post the entire plain text corpus on the internet for everybody to use, like on GitHub or something. We certainly will be able to. We will share the results of our research, of course, and there are perhaps probably workarounds for replication of such findings. But I'm not entirely sure at this point exactly how widely available they will be, unfortunately.
Thank you. Another question, I'm conducting research on predicting missing words in Arabic text. Given the complexity of Arabic NLP, I believe the study could be valuable for text restoration and machine translation. I'd love to collaborate and explore this further with you. He goes on to say, can this data be utilized for other research purposes?
I'm sorry, I didn't catch the last part of the question.
Can this data be utilized for other research purposes?
This data, meaning our data?
I don't understand the question. Mr. Amr, if you can elaborate on if you can ask the question again so we can answer it. In the meantime, I'm going to pose another question. What about Arabic manuscripts, especially those that may not be punctuated, or some of their texts have been lost due to the age of paper, etc.? How does OCR deal with them?
So generally speaking, manuscripts are much more difficult to OCR than printed text because of all the variation in the style and the script. It not only varies, of course, over time, but also between individuals. So the engine is faced with a much wider range of scripts, essentially. And so it's hard to give a kind of a clear answer to this, because as I showed you, Google Document AI can already do a decent job of at least sort of 20th century handwritten documents. What do we mean? What exactly do we mean by decent? Well, I mean, you can we can quantify this with if we have the ground truth document, and we can say it has 19% error rate, things like that. We can measure it, but I don't have those numbers at hand. As I mentioned, these OCR is very sensitive to individual features of a page, the type and level of noise. So, you can have this exact same text, the exact same sort of handwriting, but if the shading is different, or if there's a little bit of speckles on one and not on the other, you get very different output. But I would say my sense is if one has a kind of a very old document, or in a very particular handwriting style, you probably have to kind of customize your approach and kind of either do a specialized sort of pre-processing for that corpus and train a machine learning model for that particular corpus to do it well. So I know that for European languages, we've come reasonably far with medieval and early modern manuscripts. There's a consortium called Scriptorium, for example, that has machine learning models for handwritten English, French, and German, and so on. That is pretty good. But as far as I know, there's nothing comparable for Arabic quite yet. But I think, as I said before, I mean, everything is moving the progress is being made every month in this area, and given time, I think we will have usable solutions.
Thank you. Another question: have you looked into layout LLM or heuristic approaches to solve the block ordering issues?
Yeah. So I think I have pursued sort of. I have pursued a lot of different approaches, and I should say that layout parser is not the only one feasible. So there's another one which is based on the YOLO models series. So YOLO for you only look once. It's a very powerful model that identifies sort of masks or that can segment an image very efficiently for you. So that is giving quite good results for layout parser. Now the layout LLM, I've not been able to deploy to the same positive effect. Maybe it's just that I didn't do it right, but my sense was that it's for now it's kind of specialized towards identifying kind of fields on forms and so on for business documents, and it can do that fairly well. But I didn't personally get very good results for sort of historical documents of the kind that I showed in this presentation. But there are probably several paths to the same objective here, and it could well be that the layout LLM can be deployed here. I know, but I also know that both layout parser and YOLO will are kind of equivalent strategies.
Okay. 2 or 3 more questions. You must be tired, Thomas. Here's one. Are there limits on the quantity or rate of pages that can be OCR'd on the free version of Google Document AI?
So, Google Document AI is what's called as an API service. So you send messages to a server and you get something back. And most services like that have what's called rate limits. They impose limits on how much you can send in a minute or within an hour. So there are rate limits for Google Document AI. I don't remember them off the top of my head, but it's they're pretty high, generally speaking, at least for kind of academic purposes. But it's kind of to avoid people saying, sending, a million pages and then, requesting it to be processed immediately. So the service wouldn't be able to handle that, so it imposes these limits. I should mention, by the way, that there, Google Document AI isn't free. It's free in the sense that you get $300 of credits when you sign up with your Google account. But it sort of charges you from those credits for everything that you process. But as I mentioned, it's affordable. It's around 1,000 pages per dollar.
Okay. Here's a question, and it's a specific one. It's from an IT officer. It says, I'm currently using a Samsung Galaxy S24 Ultra, which has an OCR function. Can you please share what software it uses for OCR? Additionally, how reliable is it for processing Arabic text?
That's a very good question. As it happens, I have not looked very closely at the mobile app options. But I know that they are good, at least for Latin scripts. I mean, the Apple's, I think both Apple and Google, the Apple and Google built-in apps for this are pretty good. Now, if I were to guess, I would guess that the one on Android, because it's Google, is leveraging a variant of Google Document AI on the back end. I couldn't tell you what is it called Genius, the one for Apple? I don't have an iPhone, but I think it's something like that. But there is sort of a default OCR app in Apple, and I don't know what it uses on the back end. But they all work in the way on ways of servers. So that you take the picture, the phone sends the picture to a server somewhere and returns the OCR, as far as I know. Unfortunately, I can't give a better answer to that. But I would be actually interested to know myself.
Mm-hmm. Good. Another question: did you test Azure Documents Intelligence?
Very briefly, but it's so long ago that I don't remember why I didn't pursue that solution. Could it be that it doesn't have Arabic, or I may be wrong? But no, the answer is no. I haven't tried it very much. No. But I think so I know that most of these server-based, these cloud-based solutions have some kind of OCR service or kind of layout parsing option, but the majority don't do Arabic. So, for example, Amazon has something called Amazon Textract, which is really good for European languages. Yeah, just off memory, I seem to remember that was the case for Azure as well. But I can't say for sure, unfortunately.
Okay. I think this is it. Thank you so much. I think this is it for questions. I want to read a couple of comments. Someone said, I use Tabula for extracting Arabic text. Another one said, Abby Fine Reader is also available for Mac, but yet it's not very good for Arabic other than for very good pages. I guess these are the comments and questions. Elias, did I miss anything?
We're good.
Yeah, we're good. Obviously, there's quite a bit of interest in the subject. We had a very high number of participants who stayed with us for the whole period, and we went over time. Obviously, there is interest, and we hope to do a training on the subject with Dr. Hegghammer in spring. So watch your inboxes. We will advertise for it. And we look forward to it. Thank you so much, Dr. Hegghammer. Again, I want to repeat, I put it in the chat box that this session has been recorded and we will upload it on the ACSS YouTube channel. So you can see it over there. Thank you so much.
Thank you very much. Thank you so much. And thanks to everyone who took the time to attend. Thank you.
Thank you. And by the way, we had a journalist from al-Ahram newspaper.
Wonderful.
Yeah. Bye, everyone.
Thank you. Bye-bye.
Bye.